Imagine doubling performance and making your infrastructure even more secure while reducing power consumption with a big architectural leap. Sounds impossible? That's the story of Oracle Axelon. We will take you behind the scenes to show how Oracle Axelon is transforming cloud infrastructure security and performance. Welcome to First Principles. The world of AI and high-performance workloads are evolving faster than ever. The security continues to be a top priority for our customers. We need both performance and security all the time. We recently launched Oracle Axelon, the next evolution of OCI Gen 2 network architecture. Oracle Axelon is a big leap forward for OCI security and network performance and energy efficiency. Let's look at the history a bit. In the early days of cloud, the goal was multi-tenancy, sharing big, beefy hardware safely across lots of customers. OS virtualization became the backbone. OS hypervisors managed virtual machines, isolated the resources, and intercepted every network packet moving in and out through the host network interface card, or the NIC. And they also hosted security-sensitive cloud control agents that communicated with the cloud control plane. But the challenge with OS hypervisor is that it has a rich and wide surface area, and this inherently increases the chances of security threats and attacks. Additionally, virtualized network performance has limitations, and customers wanted better performance isolation with less noisy neighbor effect. When OCI launched, we took a fundamentally different approach with the industry-first Gen 2 architecture powered by off-box virtualization that was in a cloud control computer. Gen 2 architecture introduces a fully isolated hardware device called a cloud control computer that hosted the network and storage virtualization layers, as well as the cloud control agents. Think of this as a network bodyguard that sits outside, physically outside the server box, if you will, and inspects every packet and manages that. Now, the cloud control computer is controlled by OCI, and the compute instance, if you will, or the compute server is controlled by the customer. And those two are connected using an Ethernet interface. The Ethernet interface provides a simple Ethernet packet interface and nothing more. This exposes a substantially narrower surface area, thus minimizing the attack surface from customer control compute instance to the OCI-controlled cloud control computer. The packet processing is limited to simple and standard packet parsing, switching, and header rewriting. This is the key to keeping the attack surface as small as possible. After all, even the scariest computer bugs and rootkits are harmless if they're just treated like a bunch of bytes. Now, in addition to that, root of trust-based secure wipe process that we introduced as part of the Gen 2 architecture wipes all the hardware components in a very secure fashion, eliminating the possibility of malware or rootkit left by an attacker impacting OCI or other customers. The Gen 2 architecture became the bedrock of OCI's security model. This enabled us to launch the industry-first bare metal compute instance that allowed customers to use not just a VM, virtual machine, but the full bare metal compute instance. OCI's VMs were also built on top of Gen 2 architecture. What that means is that even in the rare case where there's a VM jailbreak and an attacker got out of the VM and got control of the hypervisor, they still can't get to OCI's control plane infrastructure because the cloud control computer is there and it's actually beyond the reach of the hypervisor. As cloud workloads grew, so did the network demands. In AI infrastructure world, network bandwidth demands grow at a staggering rate. Host network bandwidth has increased from 25 gigs in 2016 to 400 or even 800 gigs today. If you take a closer look at the silicon-level architecture, the Ethernet interface between the NIC and the cloud control computer requires an ASIC block on both sides to handle the Ethernet interface. These ASIC blocks consume areas of the NIC and the cloud control computer silicon, and they consume power. So it costs transistors as well as power. This power overhead scales with the bandwidth. With AI infrastructure, our goal is to maximize the power delivered to the GPUs and the AI accelerators. And as a result, we really want to minimize the amount of power we spend for various networking components. So we took a step back and we set out to reimagine the architecture from scratch. What if we have customer control NIC, the network interface card, and the cloud control computer in the same physical device, but yet fully isolated from each other at the hardware level and connected to each other via thin Ethernet interface? The result was Oracle Axelon, our evolution of Gen 2 network architecture and cloud control computer architecture. With Oracle Axelon, the host NIC and the cloud control computer components are physically on the same hardware chip, and the resources are hard partition assigned to each one of those components. The degree of isolation is critical when we bring together these two components to the same hardware. Now, it's tempting to say, hey, why can't we actually have just a chip and then use maybe a VM-type isolation to separate out the resources? A traditional VM-type isolation is easy and convenient, but we fundamentally don't believe VM-type isolation is sufficient. Instead, with Acceleron, we have architected robust, static, hardware-based isolation where the resources are statically allocated to each component with a simple Ethernet interface buffer between the host NIC and the cloud control computer component. There are no scheduler that actually allocates resources dynamically. There's no reassignment of the memory areas on the fly, none of that complexity. The resource allocation is done at boot time via immutable small BIOS-like layer, and the isolation is enforced by hardware. The key advantage is that the Ethernet interface is now entirely on chip. The traditional ASIC blocks, the MAC layer and the PHY layer, are now replaced by a simple on-chip communication channel that demands much smaller silicon and power footprint. The interface is still simple Ethernet packet parsing interface and retains a very small security attack surface and the associated security benefits, but now with less power and silicon cost and no physical Ethernet cables connecting them. Consequently, this allows us to deliver much better network performance to the compute instance for a given amount of budget of power and silicon footprint. OCI is already delivering 400 gig to 800 gig to the host and GPU with an aggressive roadmap to increase the network bandwidth even further. Well, you might ask, how about security? Well, it turns out it's actually even stronger. We have strong static isolation between the host NIC and the cloud control computer. We have a header-only inspection that keeps the customer data untouched. And we have a root of trust-based hardware wiping process that continues to be the pillars of the strong security model. Additionally, Oracle Axelon provides secure boot and validation, as well as automatic security updates to the NIC that improves the overall security posture. As an added bonus, Oracle Axelon enables automatic and secure configuration of the host NIC as well, that enables high-performance features such as NVMe presentation for OCI block volumes. Here are the key takeaways. Oracle Acceleron is the next evolution of OCI's Gen 2 architecture, designed to boost performance, strengthen security, and improve energy efficiency. With Acceleron, the host NIC and the cloud control computer components are on the same silicon, but they are hard partitioned with static, hardware-enforced strict isolation with on-chip Ethernet-style interface. The security posture is even better with secure boot and automatic security updates to the host NIC. Oracle Acceleron architecture results in significantly lower silicon footprint and power consumption that translates to much better network bandwidth performance to the host or the GPU. We already have compute and GPU instances with 400 gig or even 800 gig network bandwidth to the host or the GPU, with a lot more to come. At OCI, our goal is to deliver industry-leading performance and security. Oracle Axelon is a key innovation that helps deliver top-notch network performance with uncompromising security posture to AI infrastructure customers and enterprise customers. Thank you for joining me today.